As you already saw in the previous episodes of this series, in 1960, scientists chose the joule instead of calorie as the unit for work, energy, and heat. In terms of mechanical energy exerted by the muscles, the conversion from kilojoules to kilograms is quite simple. The energy value of a food or a drink, expressed in kilojoules, represents the approximate weight, expressed in kilograms, that you can lift to a distance of 1 meter. For example, if you see on the nutrition label of a 60-gram protein bar that it has an energy content of 813 kilojoules, it means that after eating only one protein bar, you'd have enough energy to lift approximately 813 kilograms to a distance of 1 meter. Or, if the nutrition label of a sports drink shows that 100 milliliters have an energy content of 104 kilojoules, the whole bottle gives you enough energy to lift about 520 kilograms to a distance of 1 meter, and you can find more info about the conversion from joules to calories in the 5th episode of this series. Obviously, there's no way that you can lift over 1300 kilograms after eating only one protein bar and binging on a bottle of sports drink. So what happens with all that energy? Well, contrary to what most people believe, physical activity is not the main consumer of bodily energy. You spend more energy when resting than when you exercise. Deep within, on a cellular scale, your body is in a constant state of activity. An average adult person is made up of more than 30 trillion cells, and at any given time, each cell is performing thousands of tasks, some of them being so essential for life that they are carried out by virtually all cells. And it is here, inside the cells, where the energy you need is produced. Each cell absorbs nutrients, excretes waste, detects and responds to its environment, it moves, breathes, grows, and reproduces. On a whole body scale, this amounts to a lot of energy. Moreover, according to a study published in 2021, about 330 billion cells are replaced every day. Your body also needs energy to perform other basic, life-sustaining functions, such as the synthesis, secretion, and metabolism of enzymes and hormones, the transport of ions, proteins, and other molecules, for maintaining an optimal body temperature, for blood circulation, breathing, brain and nerve function, and so on. The amount of energy needed to keep the body functioning in a period of time is known as basal metabolic rate, or BMR, and accounts for about 50 to 80% of daily total energy expenditure. There are thousands of websites, mobile apps, and wearable devices that calculate the BMR, most of them based on age, gender, height, and weight. Depending on what app or calculation formula you use, you get a different value, which, according to the US National Academy of Sports Medicine, it can have an error rate of up to 36% for obese people. That's because proper measurement of BMR requires a strict set of criteria to be met, which include being in the best possible state of health, with the body in the supine position, so there's no gross muscular activity, or, hopefully, obtaining complete muscular relaxation after 10 to 12 hours after the last meal, and at least 8 hours of physical rest, being in a state of mental relaxation, and in a comfortable ambient environmental temperature that does not elicit heat-generating or heat-dissipating processes. The main factors that influence BMR are age, gender, body size, and body composition. The younger the individual, the higher the BMR. For instance, during the first 3 months of age, the energy needed just to synthesize growing tissues and the energy deposited in those tissues accounts for about 35% of total energy requirements. The energy cost of growth falls rapidly to about 5% at 12 months and about 3% in the second year, remains at 1 to 2% until mid-adolescence, and is negligible in the late teens. Body composition is another important factor, although is not taken into account by most equations that calculate BMR. Body composition is expressed as the ratio of fat mass to fat-free mass. Fat mass, also called adipose tissue or body fat, consists of essential fat required by the body to function properly and non-essential fat, part of which provides insulation and protects the vital organs. Fat-free mass refers to all of the other organs, tissues, and cells that are not adipose tissue. Men need 2 to 5% body fat for essential functions, while women need more, somewhere between 10 and 13%. Because fat-free mass requires more energy to function, and, on average, males are larger than females, generally, men have a higher BMR than women. During pregnancy, women experience a higher BMR because of the extra energy needed for the growth of the fetus, placenta, and various maternal tissues, as well as for changes in maternal metabolism and the increase in the maternal effort, both at rest and during physical activity. During lactation, BMR also includes the energy content of the milk secreted and the energy required to produce that milk. BMR also varies with factors such as a person's mental and physical state, changes in ambient temperature, hormone production, previous diet, physical activity, and the use of drugs and medicines. When you have a fever, BMR increases significantly due to the increased rate of cellular metabolic reactions. It is estimated that for every 1 degree Celsius increase in body temperature, BMR increases by about 13%. Another factor that influences the daily energy expenditure is the thermic effect of food. Also known as specific dynamic action or dietary-induced thermogenesis, it represents the energy required for swallowing, digesting, absorbing, and metabolizing food. The thermic effect of food accounts for about 10 to 15% of the daily energy needs and varies with age, physical activity, the energy content of food, meal composition, the type of food, meal frequency, regularity, timing, and meal duration. Finally, the most variable component of daily energy expenditure is physical activity, meaning everything else you do besides sleeping and eating, including involuntary activities such as shivering, blinking, maintaining posture, fidgeting, etc. The World Health Organization recommends at least an average of 60 minutes per day of moderate to vigorous intensity physical activity for children and young people aged 5 to 17 years old, while for adults aged 18 and above, at least 150 to 300 minutes of moderate intensity aerobic physical activity, or at least 75 to 150 minutes of vigorous intensity aerobic physical activity, or an equivalent combination of moderate and vigorous intensity activity throughout the week. There are many types of activities that involve aerobic, also dubbed as cardio, and anaerobic exercise, and, depending on who you ask, the duration and the intensity of the exercise, as well as the number of calories burned, varies significantly. So let's see how the human body uses energy and what's the difference between aerobic and anaerobic exercise.